I'm Philip Simpson. I'm a category lead with AWS Marketplace, and I focus just on security. I want to start by congratulating all of you for showing up at 6:15 on the third day of reInvent. I can only imagine the sheer number of happy hours you had to walk past to get here, so thank you for that. We appreciate it. So I'm going to present today with my co-presenter, Abhinav, who's head of security for Frame.io, which is a fantastic platform he's going to tell us about for online video collaboration, and how they've taken AWS Marketplace and some of the services that we have in the Marketplace and helped automate out of Marketplace, and actually do automation on security and resolution. So the goal of this presentation is to say you've made a lot of investments so far in security and trusted partners. In your on-premise world, you have Palo Altos and Fortinets and Trend Micros. When you move to the cloud, the first decision shouldn't be, what do I rip out? It should be, how do I leverage those same trusted relationships that my CISO has approved, that my governance teams have approved, and find the ones that make sense in a cloudy world. So the first thing we're going to talk about is really, in Marketplace, how do you find those? The second part is, you've paid for many of those services. You've signed 3-year contracts, perhaps. Perhaps you're not quite ready to move to pay-as-you-go. How do you bring your licenses with you to, again, remove friction from that migration process? And where it makes sense, how do you find new security partners? And Marketplace has a huge list of security delivered as a SaaS service, and we'll talk through and do a live demo of how you might deploy one of those. So really the goal here is to figure out what you have in place today, bring with you what makes sense, change your licensing models where that makes sense, and then embrace things like SaaS and new ways to deploy those same technology partners, again, where it makes sense, and everything is unique. So we'll kind of jump in that. So we have to start every Marketplace presentation with, what is Marketplace? We're an AWS service that focuses on presenting the right software, a curated catalog of software that works well with AWS, can be consumed in multiple ways, and really helps remove the friction of discovering, testing, buying, deploying, and managing software. And that's AWS Marketplace. One of the things that many of us that have been in security for a long time are aware of is 5 years ago, 6 years ago, there was still a common misconception that when you move to the cloud, you no longer have to worry about security. We all know that's not true now, but a lot of that was really built off the AWS shared responsibility model. And this breaks security responsibility into 2 areas. One is security of the cloud. That's the underlying infrastructure that AWS manages on your behalf. The second is security in the cloud, which is really what you're focused on. The patching of your servers, the encryption of your data, that still remains with the customer. So this diagram really highlights the part that the customer is responsible for, and those yellow lines are the parts that you can look in AWS Marketplace to find software that makes sense to solve those problems. So we released some new statistics this morning on AWS Marketplace, but as of today, we have 1,500 different ISVs in Marketplace. Across those ISVs, there's 7,000 different product listings, and that accounts for, or is used by 260,000 active customers. A huge, huge consumption. About 100,000 security subscriptions are already in use out of Marketplace. This is common usage, common patterns we see from many of our customers. And that drives about 850 million EC2 hours each month just on the AMIs pushed out of Marketplace. And if you break that down, that's about 1 million hours of EC2 compute every hour that goes by being used. A huge consumption by many, many customers. Marketplace is what's called a day one service. Every time we launch a new region, Marketplace is there, including in things like GovCloud. So you can procure from Marketplace and deploy directly into GovCloud. Now, why do customers do that? They can buy software the old-fashioned way. They can call a sales guy, go play golf, drink some scotch, buy some software. Why go through the hassle of buying it through Marketplace? Well, there's quite a few sort of strong reasons to do that. The first is customers don't want to pay 3 years in advance for licenses and try and predict their usage 2.5 years from now. That's the old way of buying software, and the cloud has changed how people expect to buy software, and that includes security. We spent a lot of time over the last 7 years at Marketplace working with large vendors who have built their sales models on long-term contracts. 5 years ago, if you went to Palo Alto or Fortinet and said, I want to pay by the hour, they would not have called you back. But in this day and age, that's expected. And Marketplace pioneered and drove those changes across our security partners and indeed much of the software industry. The ease of deployment. I'll show you live in a demo in just a few minutes how fast and easy it is to deploy software out of Marketplace. What used to take days or weeks and special skill sets is now a matter of clicks, and you can spin up a live WAF and be good to go within a matter of minutes. This all seems normal now, but this was revolutionary, 3, 4, 5 years ago. Now, one thing that customers demand from us and benefit of Marketplace is they don't want to pay bills to 15 different companies for software. They want it on one single bill. But how that helps AWS customers, particularly enterprises, is everything that goes on that bill counts against any commitments you've made to AWS. So as you sign a commitment with AWS, you can help meet that demand by moving your Palo Alto license or your Trend Micro license onto AWS and through Marketplace. And we continue to evolve. Today we announced quite a few new features in Marketplace, things like the AWS Marketplace Data Exchange, which is rather than using Marketplace to buy software, now you can buy access to data and data lakes and pools of information. So for example, Change Healthcare is one of our launch partners, and they've published into Marketplace anonymized patient data. So you can now train your machine learning models with real live information. Again, so Marketplace has moved beyond software and is now doing things like data. Likewise, we have features like private offers. If you've negotiated discounts with Imperva, when you buy from Marketplace, you should have those same discounts. If you work through a channel partner like SHI or Optiv, when you buy through Marketplace, you should be buying through the Optiv fee structure through Marketplace, and Optiv will help you through that. So it continues to evolve. Here's kind of the brag slide of Marketplace in security. All the large security vendors have chosen to work with us, and again, it's not just about lifting and shifting that old technology up to the cloud, it's how do we modernize it? How do we take a traditional WAF company and turn that into a multi-tenant SaaS? How do we work with people like the IPS vendors and have them integrate with things like AWS Transit Gateway to make deployment much, much easier while still bringing all your traditional policies with you so you don't have to start from scratch? If you look at partners like Trend Micro, one of the demands and asks they heard from their customers was, when I deploy Trend Micro on-premise and on the cloud, I don't want to have two different bills. I don't want to have two different management consoles. I want one centralized way to manage all of my, in this case, Trend agents, wherever they might run. And so if you buy Trend out of Marketplace, if those agents run on VMware, on another cloud platform, it all appears in the same console, but also on the same bill. If you look at companies like Fortinet, they have a huge range of security platforms on Marketplace. They have mail gateways that can be deployed as an AMI in a traditional way, or a SaaS. You can deploy their WAF in multiple ways, including integrating with AWS's WAF. And so Marketplace isn't just about listing the technologies, but rather modernizing those technologies and improving their integration with other AWS services. We deploy in quite a few different ways. The most common way that you hear about is the Amazon Machine Image, AMI. What's important about this is how you pay for it. So BYOL, bring your own license. That, for an enterprise, is magic words. It means the current procurement relationship and systems they have continue to work as you move that to the cloud. And I'll show you in just a few minutes a demo of how easy it is to bring an IPS from on-premise to the cloud. And that's not just technology, that's licensing. How do you simplify the license move also? And most of the large partners we work with have modernized their licenses to be run anywhere. And Marketplace has worked very hard to make sure that license you bought shouldn't be limited to running on-premise. You should have the freedom to run that IPS on our cloud, on another cloud, on-premise, wherever it makes sense for you, without having to call a sales guy or pay a premium. And that's all managed out of Marketplace. Cloud formation templates were huge. I have an IT background. And when you deploy a firewall, you never deploy a firewall. You deploy a pair of firewalls. You deploy a management console. You must integrate all those together. And so if you go look at a partner like Checkpoint, you can certainly buy one Checkpoint firewall, but what you can also do is click a drop-down and say, I want a pair, deployed immediately, managed, integrated in an active state, and I want a management console deployed behind it. And with one click, all of that can happen using CloudFormation templates that the partner has built, tested, and deployed for you. So again, it makes it much easier to test out software, but also to roll up highly available environments with one click. As you might suspect, probably the fastest growing area for us is SaaS listings. And so when you look at how customers want to consume, they don't want to consume with large commitments, they want to pay as you go. And that makes much more sense in a SaaS environment. So one of the most common categories we see this evolving with is web app firewalls. And so I'll show you a live deployment of Imperva in just a few minutes. But Imperva is known traditionally as being an on-premise appliance. And they've worked with AWS, they've worked with Marketplace to say, hey, how can we make this easier to consume? How can we make it spin up in just a matter of minutes and give all the same functionality and technology and protections that you would have if you had your own dedicated box? And we do that with our SaaS platforms. Finally, we have APIs. So it makes sense in some environments to buy access to an API feed. So for example, a threat intelligence vendor might say, you can access and call and interrogate our pool of information using an API, and Marketplace can bill for that. So every time you call in, how much data you consume, and we'll bill for that on one single bill. So let's talk a couple of scenarios. One of the most common scenarios that we see, and one that's quite recently been enhanced with Transit Gateway, is I'm a large financial, I've got a critical application, perhaps my first application, I want to bring that application to the cloud. So we have partners like McAfee and AlertLogic, and in this case, Tipping Point, that have worked with AWS to integrate their technology with Transit Gateway to make this seamless. And so how do you do the second part, which is how do you avoid going back to the procurement team and getting permission to buy more licenses? Well, you don't have to. So we fully support a model called BYOL, bring your own license. And the Tipping Point example I'll show you in just a second. When you spin up that new Tipping Point AMI, it will call home and automatically get your license information. With one command, it will call home and it'll be licensed to go. And that is very, very fast and easy compared to the alternative of calling the sales guy and trying to buy a new license. So make it as seamless and frictionless as possible. But there's other ways to buy things like IPSs. Perhaps you don't want to buy that annual license, or you don't have a relationship already with a Tipping Point. You can go to Marketplace and pick out and pay for IPSs for things like number of cores behind it, number of hosts behind it. There's a lot of flexibility, so you can find not just the technology, but the licensing model that makes it easier for you. So I recorded a demo, and I had to record it because it took about 6 minutes to spin up the AMI, and I couldn't get it squashed down anymore. So I'm going to play a video. It takes about 30 seconds, but I'll talk you through what's happening. But what we're going to do is go to Marketplace, find Tipping Point, pull the AMI down, and then spin it up, log into it, and register it. And all of that takes about 9 minutes in real life, and it'll take about 30 seconds in the video. So let's see if it plays happily. So we're going to go to Marketplace and find the product that we want to find, which in this case is Tipping Point. My mouse moves very fast. We're going to deploy that out, and then this is me SSHing in to that. And I do one command, which is register this box with my management console. So I put in the information about the management console. If you look behind, what's going to happen is it will appear in my console. Now, what's awesome about that is I already have licenses. So it immediately picks up a license I've already paid for on-premise, and it's now running and licensed in the cloud. So I can check that by looking at the system logs. And you can see it's all about 30 seconds, maybe a minute from start to finish, that it takes to completely spin up an enterprise-grade IPS and leverage my current licensing investments. So I'll go ahead and deregister it, and it's gone. So you think about that scenario where you want to spin up your application, you want to test it. Now you can do all of it with your current licenses in place. Nothing new to buy, You just go to Marketplace, find the product, register with your management console, and you're off to the races. Now, the second thing I'm going to show you is a demo of deploying a WAF in real time. So before we get to that, there's a few different decisions to make when you're deploying a WAF. The first is, do I want to have this as an appliance, as an AMI? Do I want to have this in my instance deployed by myself? Perhaps I want to do it as a SaaS. And again, Barracuda, Imperva, Fortinet, they all have SaaS versions of their WAF now in place. And the third way, I'm not going to focus on too much because Abhinav is going to talk about how Frame.io uses this method and how they automate security, response, and protections using AWS WAF and managed rules. Let me spin up the second screen. So this is AWS Marketplace. I go search for Imperva. And again, there's plenty of other WAFs in here. I'm just picking this one for simplicity. I can scroll through all the different options they have. AMIs, on-demand, SaaS, pay-as-you-go. But in this case, I'm going to pick what's called Flex Protect, which is their WAF as a service. I can look at how they price. And again, I can compare different WAFs. But in this case, it's purely usage-based. I'm not paying by number of sites, number of appliances, how big the appliance is. It's just throughput. So when you're looking to test, when you're looking to grow your web application, it makes it much easier and much cheaper to start and grow with a WAF as a service, in this case, Imperva SaaS. So I can click on subscribe. Now, I've already bought this, so I'm not going to buy it again and get AWS accounting calling me. I'm going to switch over to the management console. So when you click subscribe, it just drops you right into this console. So this is Imperva's Flex Protect console. The first thing it asks me to do is, hey, what is your website? What are you going to protect? And I'm going to just plug in a domain name that I own. Creatively my name. And what it does right now is it does a quick interrogation of the DNS for philsimpson.com. And what it's going to try and figure out is, what do I have to do to point that website to Imperva? And so in this case, the traffic will be routed when the user types in philsimpson.com in their browser. It needs to route to Imperva's multi-tenant SaaS and then back to the application. So the first thing you have to do is tell it to reroute the internet. So it correctly figures out that I'm using Cloudflare today. I'll hit continue. Now, I don't have SSL on my website, so everyone's judging me, but there's nothing there. You can go to it on your phone. It just says, this is a test. But I'm going to hit that dangerous red button that says, I don't care about security at all. I don't need SSL. You could choose to have them just put a bot or an SSL certificate on the site for you. So the last step is it says, hey, you need to go log into Cloudflare and just change your A records to point to us. Tells you exactly what to do. So we'll pretend that I'm going to go ahead and do that, but that could take a little bit, so we're just going to skip that part of it. But now, had I made that DNS change, my traffic is now routing to Imperva first. So now I can do some fun things. So if I just jump into the management part of philsimpson.com, as traffic starts to go through, it will show traffic. We, of course, don't have any traffic yet. I'll click on settings. And this is where we can start treating this like a WAF. So WAFs are known for blocking things like file injections, cross-site scripting, SQL injection. And again, this has been a matter of minutes. I can turn these off or on. I can say alert. I can block the request, the user. I can turn on DDoS. So again, very quick and easy. And again, think about, I haven't actually been charged anything yet. All right, there's no traffic going through it. So it's really easy to test this scenario out and make it as quick to get it up and running as possible. They have a whole bunch of customization. You can go give this one a try. One of the other benefits of Marketplace is there's free trials for a lot of our partners. So go look, try, explore. The last thing I was going to show you while I'm in this PC is many of you probably know that AWS has their own WAF that we launched a year or two ago. And so that WAF really is a blank canvas. You can build your own rules. You can log in and customize every single rule just for your website. And that's a great fit for some customers. But other customers want that scalability and flexibility of the AWS WAF, but don't have the in-house skills to build those rules. And so we approached Barracuda, Trustwave, a whole large list of the leading WAF vendors and said, hey, would you like to build rules for our WAF? And if you look through here, there's a huge list of WAF rules. And you can click on this, deploy it right onto your current AWS WAF, and you now have the Fortinet protections running on the AWS WAF. And I'm not going to show this to you because Abhinav is going to give you a much more detailed explanation of how this works. Switch back. So with that, I'm going to introduce my co-presenter, Abhinav, who's VP and Head of Information Security for Frame.io, and he's going to cover how they use AWS Marketplace and how they automate security using those tools.
Thanks, Phil. Can you hear me, guys? Okay. Is it good? Okay. Cool. Again, thanks for attending this talk at this hour. As Phil said, I'm a VP and Head of Information Security at Frame.io. As a head, I'm managing security, infrastructure, and IT department at Frame. Before joining Frame, I spent 6 years in AT&T research as a principal researcher working on software-defined networks, IoT, and cloud projects. And before that, I spent 5 great years in Georgia Tech doing my PhD in systems, operating systems, and cloud security. So today I'll be talking about how Frame.io is blocking web attacks using AWS WAF, Marketplace rules, and serverless technologies. We are using it, then we built a system called AutoBot on top of Marketplace rules and using serverless technologies that I'll describe in this talk as well. So let me start by telling you, or by giving you a quick background on, or quick information on Frame.io. So Frame.io is a New York City startup. It's a video review and collaboration platform. So we invite team members and clients to upload their video contents into our platform, and then invite other clients and teams to actually collaborate on the uploaded assets. So we are not an editing software or editing platform. We are a collaboration platform. So you can think of us as a GitHub for videos. And needless to say that we are entirely hosted in Amazon AWS. So the first thing that we allow our customers to actually communicate or do frame accurate communication. So what do I mean by that? That they can actually insert comment and annotation on the frame itself. They can talk on the video rather than in the long email threads. And then user can actually insert comment and videos or annotation which will get embedded in the frame itself that allows very easy navigation. The second thing is that we act as a security hub for film production. So teams can see who is doing what in the platform, and they can also manage different versions of the asset or videos. So that's basically single place, you can see everything. One other thing that we allow is secure sharing of videos. So sometimes you want to collaborate with people that are outside of the platform. So you can share content in a secure manner with external partners. You can also customize who and what they see, how and what they see. So as I said, that we are not an editing tool, we are a collaboration tool, but we do allow integrations with popular NLE editing systems like Adobe Premiere, After Effects, Media Composer, and so on. And these integrations allow editors to directly upload contents into Frame.io and then again share with the internal teams or external partners. These value propositions have actually enabled us to accumulate a great set of logos over past few years. So some of the companies you can recognize here, we are working with them. So let's transition from a 30,000-foot overview of Frame.io to actual platform that we are running in AWS that is actually enabling all those features that we just talked about. So we have 2 kinds of cluster in our platform. One is Kubernetes cluster based on EKS. Another is a normal containerized cluster that uses ECS. And we process 2 kinds of workloads in our platform. One is users' web requests that are related to user management, permissioning, team creation, and so on. And for that, when user sends a web request, it hits the load balancer, and then it gets transferred to one of these clusters, depending on the load. Behind the scene, we use Postgres database for storing transactions, and all the videos are stored inside S3 bucket. The other workload that we process is related to video transcoding. Whenever someone uploads a video in our platform, we perform transcoding on that video to generate low-resolution proxies. So even bandwidth-constrained devices or users can perform review and collaboration. All of our workload execute inside a VPC for security reasons. So in this platform, you can see that we are a SaaS company, and this system platform is accessible over internet. So we do get a lot of bad requests along with good ones, right? So as you can imagine, people are trying to break into the system. They are trying to send malicious requests, SQL injection, cross-site scripting, and so on. And to protect or block those malicious requests, the first thing that we do, we deploy AWS WAF. So AWS WAF is the first layer of defense that we have in our infrastructure. And AWS WAF is a pretty cool service that can block a variety of attacks based on the signature that it has. And you can deploy it at many places in front of load balancer, or also in front of CloudFront as well if you are doing static hosting. So some of the things that AWS WAF allows, that it can allow you to write your own rules. You can create your own access control list. You can have a different way of deployment, as I mentioned, in front of CloudFront or in front of load balancers. And all these things basically help you create a system that can protect against all these malicious requests. But the problem with any firewall system, whether it's a web application firewall or network level firewall, is that how do you write a good rule set that can actually block the traffic? Because rules are actually heart of any firewall. Firewall in itself is just a container that executes all those rules. And developing good signature is very hard, right? Because you need to provide a fine balance between false positive and false negative, right? If you write a very broad signature, right, to detect, let's say, SQL injection, you may end up blocking legitimate requests. And if you write a very narrow set of rules, right, just to catch one case, you may miss some attacks. And this is the balance, and providing this balance is very critical if you don't want unhappy customers. You also need to have a good threat intelligence in order for you to write a good firewall rule, because you need to know what kind of attacks are being seen in the wild, what kind of exploit are being written by the attackers, so that you can write rules for that. And all these things require resources and testing, right? Because once you write a rule, you need to test in development to make sure that they are working before you move into production. And for these reasons, we decided not to craft our own rules, right? Because we didn't have that kind of resources in the company. And we decided to use Marketplace WAF Rules. So we looked around in the marketplace, try to find which WAF rules to work with, and we landed on these two rules, Fortinet and Imperva. Fortinet is Fortinet has a rule called OWASP top 10 blocking rule, which basically blocks SQL injection, input validation attacks, bot detection, local or remote file inclusion, and so on. And what Fortinet's OWASP top 10 rule does, it basically blocks each individual malicious request. So if an attacker sends thousands SQL injection malicious requests, it will block all those 1,000 requests one by one. On the other hand, Imperva rules set that we use, it's based on IP reputation. So it doesn't look into individual requests, it looks into the reputation of an IP address. If IP address is has been involved in the spamming activity, has been part of the botnet command and control, it gets picked up by Imperva's sensors, and basically Imperva adds it in its blacklist. And when when those IP addresses try to send requests into our platform, they get blocked. So it's an IP blacklisting. Imperva does a lot of crowdsourcing to find threat intelligence from various sources, and it keeps adding new sources as well to keep the list fresh. And these two rule sets complements each other, right? Because Fortinet is blocking individual requests based on whether they are sending malicious payload or not, and Imperva is blocking based on IP reputation without worrying about whether those requests are good or bad. So many of these points are actually covered by Philip, that AWS WAF rules are very easy to deploy because with few clicks, as you saw in the demo, that you can have these rules up and running inside WAF. You get integrated billing. Again, with a single place, you can see all the WAF rules cost. You don't have to log into any vendor portals. And again, you get a single pane of glass view. Because AWS actually last September, they released WAF data as well. So now you have a WAF log data where you can see all actions performed by those rules. And that includes vendors' WAF rules as well. So you can see with the single log data, you can see how your firewall is performing, how those rules are performing, whether they are blocking legitimate traffic or not. So that single pane of glass view is pretty good for us to, when we look into WAF data, to basically see how our firewall is doing. The downside is that they are not very extensible because a vendor rule, you can't go and add your own rule, or you cannot change its logic if you think it's not working correctly. And then there is no API access. Since we are buying WAF rules, so it's not that we are buying a vendor appliances, so there is no API access where we can make changes. This is not a deficiency. This is not a deficiency in the rule itself, because rules are supposed to work just like a rule. But since we wanted to build few systems on top of this WAF data, this WAF rules, and that's when we hit the roadblock that without having an API access, we couldn't build it. But we solved this problem using WAF log data and serverless technologies. So AWS has a bunch of serverless resources, right, or serverless technologies. Lambda as function as a service, where you can run Lambda functions without booting any VMs. So you don't have to, it's a managed service, you don't have to worry about servers or cost. You pay only when the functions are invoked, so there is no fixed cost. Then there is a message bus Kinesis Firehose that basically can take as much as data you want to send through it. And then you have a notification service that allows you to communicate between Lambda functions and other resources. And last but not least, Elasticsearch, which is not part of the serverless service, but it can act as a SIM system in the cloud, right? Because it allows you to store all that data, and then you can query that data later. So the system that we build actually uses WAF data and serverless technologies. And within the serverless, we are using these two design patterns. The first pattern is called event-driven serverless pattern, where Lambda functions are actually subscribing to some resources in the clouds. For example, Lambda can subscribe to an S3 bucket. And whenever there is a put operation in that S3 bucket, that Lambda function can be invoked. It can process that object that was just stored into the S3 bucket, and then it can go back to sleep. And event-driven model is very heavily used model in the world of serverless. The second design pattern is called periodic invocation Lambda pattern, where Lambda functions act as a cron job, right? Where CloudWatch can invoke these Lambda functions every minute, every hour, or every 24 hours, depending on your usage model. And at those times, these Lambda functions will be invoked. They're going to do their job, then pass the results back using some asynchronous mechanism or message bus or through email, and then they can go back to sleep. We use Lambda functions in our platform a lot, even in the transcoding pipeline, in the security systems that we develop. We came up with 6 design patterns, and we even wrote a research paper last year and published in Hot Cloud Conference. So if you are interested in serverless design pattern, check it out. So let me describe the system that we developed. The system is called AutoBot. It's an automatic response system for signature-based firewalls. What AutoBot does is it incorporates an IP blocking capability on top of Fortinet's signature-based blocking capability. And it uses, as I mentioned, the serverless technologies. So let me describe the problem. So as I mentioned that Fortinet or any signature-based firewall blocks traffic based on whether the traffic pattern matches the malicious signature pattern or not, right? So for example, if there is a SQL injection attack and the firewall has a SQL injection blocking rule, if it matches, the traffic will be blocked. But think about it. If an IP sends you 1,000 SQL injection cross-site scripting requests, HTTP requests, then signature-based firewall will block all those 1,000 requests one by one individually. It will never block the IP address. From our perspective, when an IP is sending so many bad requests, we don't want to work with that IP. We don't want business from that IP, right? We want to block actual IP so that we don't want to guess what is going to come next from that IP address, right? And an AutoBot builds that capability on top of that firewall. You may ask that you have a Imperva firewall. Imperva should block that IP. Yes, Imperva should block that IP. But the problem is that Imperva can only block IP if that IP is part of a known bad IP, if it's in the known bad IP list, right? If the IP is not known bad, it's an unknown IP, its reputation is not yet known, then it's not going to get picked up by Imperva's threat intelligence sensor. And if it's not there, then it will go through. The traffic will go through from those IP addresses. And to solve that problem, we developed this system called AutoBot. So the first thing that AutoBot does, it basically it develops WAF analytic pipeline. So what happens, AWS provides WAF data. So in order to get that WAF data, we pass the data through Kinesis Firehose and then store inside the S3 bucket. Now there, in that S3 bucket, we have an event-driven Lambda subscribed to this S3 bucket. And as soon as WAF records are written into this bucket, Lambda function gets invoked, and it basically processes that log. And in the processing stage, it basically enriches that log. So vanilla AWS WAF data has only IP addresses. What this Lambda function does, it adds geolocation also with that data. In the vanilla AWS WAF data has rule ID, access control, list ID, and all those things. In the enrichment phase, we add rule names such as this traffic is blocked by Fortinet OAuth top 10, or this traffic is blocked by Imperva IP reputation, so that our data has, so that our stored data should have a lot more context. And then we pass that data back again through Firehose, and then it's stored in the Elasticsearch. And now our data is stored, enriched data is stored in the Elasticsearch that we can query, and we can look into what is happening. So in the next step, we write periodic Lambda invocation function. Now what happens in this stage that this Lambda function gets invoked by CloudWatch event, and which runs every few minutes, and this Lambda function gets invoked. It reads from a configuration file that has notification logic and threshold value. And then this Lambda function queries Elasticsearch asking for that, tell me how many IP addresses have been blocked, or sorry, how many requests have been blocked from each IP address. And when it gets the data from Elasticsearch, it uses the threshold configuration to decide whether the block count for any given IP is above the threshold. So for example, if the threshold is set for 100, if Fortinet blocks requests, more than 100 requests for a given IP, then that IP should be blocked. If the threshold is 100, then it checks the data that is extracted from Elasticsearch, whether any of these IP addresses count crosses the threshold or not. If there is an IP address that should be blocked, then it fires up an SNS event and invokes another Lambda function. And this Lambda function, what it does, it first notifies security analyst or security team on Slack saying that we have seen this IP, now we are going to block this IP. And then in the next step, it basically adds that IP into our blacklist that we run on WAF, and that IP is added into the blacklist now. So it's a completely automatic system. We don't have to look into that. It just keeps working on itself with the help of periodic invocation Lambda and the event-driven Lambda pattern, and then we can keep seeing the results on Slack. Just to show you the security notification that we get on Slack, so it sees that a blocked request exceeds the threshold value, right? Because that was a threshold value. We have some threshold value. So this IP sent us 483 bad requests, right? And Fortinet blocked all those requests, but then it didn't block the IP address, right? So once we see this notification, we know that what is going to happen next. The next is that IP now adds this, so that Lambda function will add this IP into the WAF blacklist. And it adds both, it adds on CloudFront as well as on the load balancer. And with that, these IP addresses are now part of the blacklist, so we will not receive any requests from that IP, or we will not process any requests coming from that IP address anymore. So in this way, we basically we actually enhanced Fortinet rule set and actually gave it a capability of IP blocking, right? So it's like a best of the both world. Like in the Fortinet world, now it can do signature matching, but when based on its own action, if the signatures, if the IP is acting maliciously, it can go and actually block it. So we made some more, so we added some more blocking capabilities into our platform. So we did similar automation for Tor blocking as well. So now our Lambda functions mine Tor exit nodes every morning and gathers those exit nodes addresses and adds into our WAF list so that we don't receive any requests coming from onion routers. And we also developed an anomaly detection system to complement the signature-based capability of Fortinet. And that system actually uses machine learning and AI and uses SageMaker and, again, serverless technology to actually block traffic based on anomaly detection. So anytime when attackers are smart, they try to evade the system by evading the signatures, our anomaly detection system picks it up and blocks that IP. That's an entirely different talk, and we will talk some other time. That's all I had. So if you are not using Marketplace, do try it out. If you're not using WAF rules from vendors or from the Marketplace, do try it out and see how you can enhance it using serverless technologies. Thank you.
So just one last slide, and we'll do the quick takeaways, and I promise you happy hour is just a few minutes away. So here's what we covered today. We covered, how do you remove friction when you move to the cloud? So the first thing is look at the platforms you currently have. Don't look to get rid of everything as you move to the cloud. Who do you trust? Who do you have relationships with? And we've probably worked with those same partners to make sure they're available, not just in their current licensing model, but in pay-as-you-go. Keep using the licenses you have where it makes sense. As they start to expire, perhaps look at more flexible ways to consume. And then as you evolve, start looking at SaaS platforms. Can you get the same technology in a faster to deploy, easier to consume fashion? And then as Abinaf so well highlighted, start building on top of those platforms. How do you automate? How do you integrate? How do you look at other AWS services and take advantage of that additional context and information? So with that, you guys are off to happy hour. Thank you very much.